Wonderful. Welcome everybody from my end. I'm Stefan KRÜMPELMANN. I'm the editor of the Hydrogen and Future Fuels service at Argus Media, and I would like to welcome you all to the session number 3, which is going to be about eFuels and the green revolution and the fueling change, strategic use of eFuels in the hydrogen economy. Welcome all from my end. I'm delighted to have 4 excellent panelists with me today. The way that we're going to do it is we're going to do 5 short presentations, snappy, couple minutes each, just introducing what our respective companies do, and then also a bit of an intro in terms of how we view the industry and the sector. Before I just launch into mine, just a couple of words about the panelists and who we have here. So, just to the left of me is Gilles, who is Environment and Sustainability Marketing Manager at Airbus. Then next to him, we've got Yassin, who is Senior Commercial Manager at the Rotterdam, the Hague Airport in the Netherlands. Next to him, we've got Thorsten SCHNORBUS, who is Senior Project Manager for Corporate Research at German company FEV. And then on the far end, as far away from me as anybody, is Younes, who is Country Manager for MGH Maroc. They will all introduce themselves in a bit more detail in their respective presentations. What I would like to do just very, very briefly now is setting the scene, so to speak. Why are we even talking about eFuels? Why is it such a hot topic? Why is it so interesting to speak about that at the moment? Launching into my presentation, just a couple, the usual notices about Argus. We are basically a business intelligence provider / price reporting agency. We're reporting on pretty much any commodity you could possibly think of that is traded, or in the case of hydrogen also that's not traded yet. And for hydrogen specifically, I head up that service, and we provide news and analysis, model production costs, data sets, and so on and so forth. If you're interested in learning more, please feel free to approach me afterwards. Always very happy to have a chat. But really what I want to do is just give a very, very brief overview, 2 slides with a couple of graphs and data. Why is it such a hot topic, especially eSAF at the moment? And the answer to that partly is, of course, we're close to the EU, and in the EU we've got mandates now for eSAF use, which start fairly modest at 1.2% in 2030 so 1.2% share in overall aviation fuels by 2030. But then they rise quite steeply. And by 2050, they're as high as 35%. And as you can see on the graph on the right-hand side, that would amount to nearly 25 million ton per year of eSAF demand by 2050. And you can see on the left-hand side the projected production capacity based on our data sets. We are getting somewhere close to 3 million tons per year by 2030 based on everything that's announced. The bulk of that, unsurprisingly, in Europe because of the mandates. I should say a lot of that is still, almost all of that is still very early stage. We basically have hardly any plants in operation, very few at FID. So there's a long way to go, but it certainly gathered pace over the last few months and years. And fairly similar picture when we talk about another e-fuel, when we talk about e-methanol, which is interesting in particular, of course, for the shipping sector. That's where it's touted as one of the big solutions for decarbonizing. Again, right-hand side graph, you can see our in-house projections for kind of maritime fuel use going forward, and you can see that kind of turquoise patch is for hydrogen derivatives, low-carbon hydrogen derivatives fuels. And you can see how that kind of opens up from 2030 and grows significantly up until 2050. A lot of that's going to be ammonia probably in the long run based on our projections, but still also a lot of e-methanol in the mix, especially in the beginning, and also their production capacity expected to rise quite considerably over the next few years. Again, similar situation, all very much early stage, but certainly a big increase to be expected, even if just a fraction of what's announced is realized on time, and I'm sure there'll be many more announced projects going forward. So really interesting topics, partly because of those mandates, partly because of these interesting applications in the transport sector. And that makes me even happier to have these excellent panelists here, because they can all tell us a lot more about it and tell us how these things are progressing and what they are specifically working on.
So, thank you. And definitely, yes, I will confirm SAF and eSAF are and shall stay a hot topic for aviation in the future. and you will understand quickly why. So I work for Airbus Commercial in the marketing organization. And for us, SAF and eSAF are clearly a key enabler for the decarbonization of our sector. Before entering into this topic, just a few words about Airbus. Airbus Group, it's a worldwide company, an aerospace company, which is made of 3 divisions: defense and space, helicopters, and the most famous one, Airbus Commercial. Here you have a few figures. We design, build, and deliver aircraft to more than 400 customers all over the world. We have a backlog of more than 8,000 aircraft to be delivered. So we are very proud of our products, services, and we want to deliver as much great value to our customers as possible. But we are really conscious of our responsibility, and we want to do more and to deliver a positive impact on the people and on the planet. We know all that we are facing one of the biggest challenges of our lifetimes with climate change, and we want to lead the transformation of our aviation sector into a more sustainable one, because we do believe that it will be our license to operate in the future. So that's why we set our purpose a few years ago, which is to pioneer sustainable aerospace for a safe and united world. Having said that, after the purpose, we need actions and we need a roadmap. So we set a roadmap, a concrete roadmap that supports the decarbonization ambition of the sector, which was announced and released a few years ago by international organizations like IATA, ATAG, supported as well by ICAO, the International Civil Aviation Organization, to achieve net zero by 2050. And we have at Airbus our own roadmap to support this net zero target by 2050. First stage is 2030, where we want to achieve significant reduction of our scope 1 and 2 emissions compared to 2015 baseline. And in parallel, we want to make sure that all our products will be compatible with 100% SAF. Next stage is 2035, where we want to achieve a 46% CO2 intensity reduction of our scope 3 emissions, targeting the use of our sole product. Those targets have been approved by SBTi, by the way, and at the same time, we want to launch our hydrogen-powered aircraft, concept aircraft called ZeroE, as you may have heard about. So we have a roadmap. Now we need a toolbox, and we have one toolbox, which is made of many different levers. There is no silver bullet solution for aviation to decarbonize, and we are fully aware of it. We need to push each and every lever to the maximum in parallel. They will need to deliver all the maximum yield, I would say, in terms of decarbonization. It will be first about reducing the fuel demand, acting on the fuel consumption of our aircraft by renewing the fleet, by developing technological bricks for our future platforms, for weight savings, for more improvement in terms of fuel efficiency, work also on operational efficiency in terms of air traffic management, optimization, for instance. Carbon capture, carbon offset will also play a role in order to tackle the remaining emissions, but the elephant in the room here is clearly about SAF, Sustainable Aviation Fuels, that will have to play a predominant role in the future in order to achieve by 2050 about 50%, depending on the scenario, of the total jet fuel demand if we want to be net zero by this date. And among those SAF, eSAF will also play a predominant role in order to scale up the production, to overcome the limitations in terms of biomass, I would say limited availability that we will reach at some point. So clean energy and SAF are clearly the big elephant in the room. And just to conclude, I would like to talk about hydrogen, which is acting behind the scene, I would say. For us at Airbus, this clean fuel, this low carbon fuel, is clearly one of the most promising fuel in the future for many reasons. Well, in fact, it's for twofold reasons. First, it's about the direct usage of hydrogen at aircraft level. Because when you use hydrogen, either through fuel cells to power electric engines or through direct combustion into modified gas turbine, you do not emit CO2 emissions. So that's a very important fact. Second, it's about the fact that hydrogen also is a key input for the production of power-to-liquid fuel, meaning eSAF, and we will need, clearly, those SAF to scale up the production and to achieve our net zero target by 2050. So all in all, we are fully aware of the challenges that we are facing in terms of SAF, and at Airbus we want to act as a catalyst to contribute to the scale-up and to the emergence of the SAF market in the years to come.
Thank you very much, Gilles. And then we've got Yassin next, and he can tell us a bit more about this topic from the perspective of an airport operator.
Yes, thank you. The mic works. First of all, good afternoon, everybody. Assalamu alaikum. My name is Yassin SADDIKI. I work at one of the Dutch airports in Holland, Rotterdam Hague Airport. Just like my colleague mentioned, we as an airport, or maybe you can ask yourself, what is the role of an airport in this whole transition? We try to be one of the enablers from an airport point of view. We try to speed up the process in using eSAF for the airlines and also the fuel suppliers. We don't have to forget them, of course, how to speed up the process. The airport is a middleman in this process. What we try to do is find the perspective from both sides, the fuel supplier as the airlines, because currently the SAF price, eSAF price, isn't cheap. But the question for us as airports is how we can enhance and speed up the process of using the SAF that is available in the market. What we do is we have set up a goal in the upcoming 5 years where we try to go with all the departing airlines from Rotterdam as the innovation hub in Holland to set up a confirmation of 2 till 14% of using SAF on all the flights leaving from Rotterdam. So that's very ambitious because at the same time our fuel supplier also gave us a heads up, okay, well there's not enough currently in the market to facilitate that. That's an ambition, of course, but we try to help the airlines with incentives because to don't push the price of a ticket too much, too fast, too high in the upcoming years. So the role of the airports are the middleman, trying to help both chains, the airlines and the suppliers. It isn't an easy task. What we see in the current negotiations with airlines as fuel suppliers, but we have to start. And that's what I like also about this summit is we need to stop talking and start taking action and just try to start somewhere. And eSAF is for me a good example in how we can facilitate also the part of the process from the airport point of view. So, and another thing is we're currently also going to start with the Moroccan airports to talk with our counter colleagues in Morocco to see how we can organize all the flights leaving from Rotterdam to Morocco with eSAF on both sides. So these are ambitions, but doable and makeable. I see a question in the audience, I thought. Oh, I thought I saw a question from the audience. So these are the key topics for us to share here, but also if you have any questions, don't hesitate to ask.
Thank you, and then we've got Thorsten next.
So, yes, welcome from my side as well. So, my name is Thorsten SCHNORBUS. I'm working for FEV. FEV, you might not know it. It's a global engineering service provider with roughly 7,000 people. We have different business lines. We're coming from the automotive sector historically, so we develop powertrains, electric powertrains, fuel cells, and also combustion engines, obviously from the past, but we still, of course, do in some parts of the world. Then is the aviation part. We look into very much also the energy side, which we are here now, and we have a large consulting branch which does very technical consulting. And in this regards, we do have a quite unique selling point because we look as a company into very much detail of technology. That means we help in electrolyzer development, we help in fuel cell development. We can look into the aging of these things. We then have the strategy branch where we do really consulting, bringing this deep technical knowledge into strategy of companies or airports. And then the implementation part where we look into supporting project development. We are not a project developer, we're not an EPC, but we look into conceptual design and also controls of future Power-to-X plants. So the transportation sector in the future, of course, will look different very much. And of course, as our consultancy that's their job, doing large studies also for companies like OGCI, which is the Oil and Gas Climate Initiative, to see how a possible trend or possible shift towards renewable energies can look like and how a share of different energy carriers can look like. So we have there a very, very important contribution of Power-to-X, obviously. There, of course, the biomass will also play its role. Of course, we will see that this might look different in the future, but what you can see as well is that there is a massive demand of liquid energy carriers, be it for aviation, for shipping, or for chemical industry. Even though we see a little decline, that means by more electric transport, we will have a bit of efficiency gain, which will probably be more or less overcompensated by increase of transport demand. So therefore, there is a massive role in green energy carriers on the chemical side. In this regards, we are part of several projects. One of these is the biggest German project running on renewable gasoline. So we do have a Ministry of Economy, Transport, Finance project where we do e-gasoline on this project, several million liters, which is used methanol actually to create then a gasoline, an EN228 standard gasoline. You see here Minister Wissing refueling a car in this event here. And this was, of course, for us the base and the project before that and other projects to look into what is the pathways for also creating green methanol. In the end, of course, we see this project concept which we developed here, using sewage sludge and green energy to create green methanol as a kind of bridge, because you have a kind of hybrid fuel of bio and RFNBO mix, which generates also a very interesting business case because you get some of the hydrogen and the CO2 more or less for free because sewage sludge is globally recognized as waste. It's not a competition of food or something. So this is a very interesting concept, but as you see as well, it's a bit decentralized system because carbon sources are not central in the future. I mean, there's very rare, very big carbon sources. That means we need to look into a modular system, which we can then scale up by numbering up more or less across the world, and there is really a lot of waste available to do these kind of concepts. So that's a bit of a base idea where we're from. Just as one addition to this concept, which we investigated here for a German, and in this case a Tunisian case, we see that this fuel coming out of this concept can be carbon negative. That means we really avoid carbon emissions. I mean, we collect the carbon from the air. In the end, the waste is always, in the end, was plants before, so it's kind of air capture, indirect. And then we avoid another greenhouse gas emissions by burning sludge or by dumping it in landfills. That is a big red column there, where you see there's a significant carbon negativity coming from avoided methane slip. That means this fuel is really capable to serve any purpose. It's shipping or methanol to kerosene or even on the road transport sector to avoid carbon emissions and have a carbon negative transport system. So just some key takeaways, but I think that's not needed, but I think we can happy to discuss a bit more details later here.
Wonderful, thank you so much, Thorsten. And then we move on to Younes to share his insights from Morocco specifically.
Hello, everyone, and welcome to the session. My name is Younes HAFFANE. I'm the country manager at MGH Energy Maroc. As you might have guessed from the cover slide, our objective is to decarbonize the maritime and air transportation sectors. We do that by developing integrated projects, going from the renewable energy production to the production of e-methanol and e-kerosene. We took a specific bet on these particular e-fuels for 4 main reasons. The first one being the energy density. You can cover longer distances with methanol and kerosene as opposed to hydrogen, for example. And so we think this is a very key element for heavy long-haul transportation. E-fuels are considered to be drop-in fuels, meaning that you might need to do some minor retrofitting on your existing engines, but definitely not a total redesign or a total replacement. Third element is the favorable regulations. Stefan mentioned earlier Refuel EU Aviation and Fuel EU Maritime. So very interesting regulations driving up the uptake of e-fuels. And finally, the fact that e-fuels provide countries that are involved in the sector with the opportunity to reduce their dependency on the traditional sources of energy, while being a good driver for industrial growth. Once we set up our minds on e-fuels, we started looking for the best spots worldwide, where climate conditions are very suitable for cheap electricity production. So we identified geographies where wind speeds exceed 9 meters per second and where the solar irradiation goes over 2,200 kilowatt hours per square meter. And as you can see, there are not that many spots worldwide where the two conditions overlap, and we are very blessed here in Morocco to be very well positioned at the doorsteps of Europe, where the majority of the offtake is supposed to take place. And just to give you an idea about the great potential of the country, if you decide to dedicate all your potential towards the production of e-methanol, you would be able to cover 150% of the maritime industry global needs. And if you decide to do the same thing just in Morocco alone for e-kerosene production, you would be able to cover 80% of the sector's global needs. So this speaks volumes to the country's very enormous potential. And within Morocco, our choice for the project location was very obvious. So we picked up Dakhla, obviously for the climate reasons, but also for one of the main mega projects in the country, the ports of Dakhla Atlantic, and also the high quality and availability of land, which is very suitable for large-scale projects such as ours. And so, as such, we developed Yassin, our project, as a part of the green Moroccan offer for green hydrogen, with considerations of horizontal and vertical integration in mind. R&D is also part of the project's DNA. And on the downstream side, while the primary objective is to produce e-methanol and e-kerosene, the project is designed to have a strong positive impact on the local territories by developing, obviously by creating direct and indirect jobs, but also by developing local activities such as agriculture and breeding activities using excess desalinated water and surplus green electricity. And finally, just in terms of structure, the project is developed by MGH Maroc, which is a Moroccan company based in Dakhla with two partners. MGH Energy, which is based in Montpellier, chaired by Jean-Michel Germain, with more than 30 years of experience in renewable energy projects development in Europe, but also in Morocco, with the first wind farm developed in 1998 by La Compagnie du Vent, and the first private wind farm developed for Lafarge in Tétouan in 2004. And on the other hand, the company Nataej, owned and chaired by Mr. Driss Benhima. Thank you very much. That's all for me.
Perfect. Thank you so much, and thanks to everyone for these really insightful presentations. I think we've got around 20 minutes or so just to discuss some of these topics a bit further. So I'm just going to ask a couple of questions, which I'm happy for all of you to answer, of course. I am also just putting a word of warning out there. I might ask you in around 10 to 15 minutes, you as in the audience, whether you've got any questions. So please start to have a think about what you might want to know from our panelists, and I will come back to that in a little while. Before I just open it maybe to all of you, I would actually just start with you, Younes, again. Obviously, that all sounds really interesting, and I think for everyone who's kind of familiar with where Morocco is at, that sounds quite plausible in terms of the renewable capacity. What are then the kind of key challenges to actually realizing this, both from kind of a technical or financing or logistical point of view? Because obviously we're not there yet, we're not nearly there yet, neither your project nor pretty much any other. What are the challenges then?
So I think the biggest challenge would be the CO2, but I'll leave that to the end. So if we look at the eFuels value chain, we can see all the elements of the chain and see exactly where the obstacles or the bottlenecks are. If you take the renewable energy brick, this doesn't represent any technical challenge per se, because we know how to develop and build and operate these plants. But in the context of the Moroccan offer for green hydrogen, I think the limitation would be the land, so the space where these projects would be developed. And so from that perspective, it would be very interesting to see how equipment manufacturers, I'm talking about PV and wind turbines manufacturers, could enhance the performance of their equipment so we can have more capacity installed in a given perimeter. Desalination, also another mature technology, so there is no technical challenge here as well, but it would be interesting to see how we could achieve economies of scale, because it doesn't make sense for each project to have their own desalination plant. And so this is more of a governance slash financial engineering type of challenge. Electrolysis maybe comes with some question marks in terms of which technology to use or to select between PEM, alkaline, SOEC, and so on, and how to scale it up to the multi-gigawatt level in a way that doesn't hurt the final cost of production. And so coming back to the CO2, I think this is the one brick in the eFuels sector context that poses the greatest amount of challenges. And at MGH Energy Maroc, we are exploring different paths, different options at the same time, from trying to locate biomass sources to seeing how we could capture CO2 at industrial plants here in Morocco, to even exploring direct air capture. Another challenge is the supporting infrastructure. So in order to hold all these elements together in a value chain that makes sense, there is a need for a heavy supporting infrastructure that calls for heavy investments and innovative funding models. So this would be our take on that.
Understood. Thank you for that. And Thorsten, maybe I can continue with you and kind of ask you a fairly similar question in terms of what do you see as kind of the challenges in terms of getting there? And I have one specific question linked to that, because I think this idea of, I think it always sounds extremely appealing, this idea of, converting waste into eFuels of some sort. So what are the challenges specifically maybe also to that, and how scalable is that, for instance? How replicable is that in different locations?
Yes, so maybe starting with the first thing, I think main challenge for the bigger project at least is long-term offtake, really. That's what I see as a challenge, because there is a quotas which we just saw, but in my view the quotas are by far not high enough to initiate a significant change. We do studies also for the OGCI, as I mentioned, and these big companies need a big push, otherwise it's hard to start moving, really. So from the CO2, I have a bit of different perspective. I do see, that's also against many big companies saying we need massive sources of CO2 in one central place. Yes, that's nice if you think in the oil and gas business, because that's what I used to, 4 gigawatt plant in Dubai or whatever, that works with a large scale, but it has to change in this way. I think, first of all, numbering up by a kind of serious production, that's key also for electrolyzers. If we don't make them in mass production, we will not manage any goals. And that, of course, is not a unit of a gigawatt each, it's small units, and you just put them next to each other. Technically, otherwise, it's not really possible. So that means serious production is key to get this rolling, and if we do serious production also in this concept which I showed, you can make it quicker in the end. So once we have permission done for a country, you can build it 20 times on different places because always more is the same. Of course, you need to adapt a bit on the local energy resourcing or energy sourcing. Wind and solar is everywhere a bit different. We are discussing the same concept in Brazil. It's hydropower, easier, principally, the net is green already. So it works more or less everywhere. And if you count this CO2 source of sewage sludge around the world, it's easy to cover roughly 10% of the fuels. That's not covering all the fuels, but it's a starting point. And once we are there and have used all of that, let's discuss the next steps. We will, of course, go in the long term for air capture and all these kind of things. But I think we have to start with the low-hanging fruits because the hurdle to get into this market is anyway high enough. So let's start with something which is economically most viable. Even not easy, still not easy.
Yeah, understood. And I saw some fairly vigorous nodding here when you made that point around the targets and the policies. And Yassin, obviously, you mentioned, you know, we need to move now. We need to do something. So maybe both to you, Yassin, but also to you, Gilles. How do you see where we stand in terms of, you know, policy and incentives for kind of making this happening? Are we where we want to be, or what else do we need?
You know, in the aviation sector, what we see is the off-takers, airlines, airports, fuel suppliers are a bit waiting on each other. For example, the European legislation is telling us to do 2% on eFuels on SAF upcoming year. What we do as an airport is, like I just mentioned in my introduction, is that we're asking for more than 2%. What happens in the market is that the airlines, the suppliers are asking, why you want to do more than 2%? Well, we feel the need and a responsibility as an airport. And that's why what we do is we ask more to fly from our airport as a hub. We ask between 2 and 14% in the upcoming 5 years. At the same time, the airlines are very, well, price hurts quickly in the airline business. So we give them incentives to promote, help them bridge the gap in doing more than a 2%. At the same time, what we see is that the market has to get used to adapting SAF as a mainstream fuel. Everybody wants it, but we are eager. We are trying to do more than legislation is telling us. That makes that we have, negotiating, of course, is one of my current hard jobs that I'm doing currently. But the big fuel suppliers in Europe and the airlines, they're all willing, and everybody's a bit, not cold feet, but we know that we are going to take that big jump in the upcoming years. But you need some first movers, and we try to do that and facilitate it in the possibilities that we have. And in terms of incentives, what we do is we help charging the airlines less from the airport charges. That's the incentive that we can use to promote using SAF. It's not easy. What I just mentioned also about Morocco, all the destinations flying from Rotterdam to Morocco are a beautiful way also to combining countries. So it's not just a thing from Holland to do, but also in Morocco. So we're in the upcoming period, we're going to start also talk with our Moroccan colleagues to have flights from Holland to Morocco and back with sustainable fuel. And the thing is, you have to organize it from both ways, infrastructure, the fuel suppliers in Morocco. So we're here to share knowledge, and like the ministers told us this morning, we need to step into action. And we feel the urge. So I think we took the first steps, and but it's challengeable. It's very challengeable in this upcoming period, I think.
Yes, it's a very challenging period. And coming back to the regulation, I would say that it's maybe one of the biggest topics to address. The airline business is a global business. They are flying everywhere. So they need a level playing field, or at least a certain, I would say, vision of what will be the regulatory frameworks in the different regions they are operating. As of today, for SAF, the regulatory framework is highly too fragmented. You have 2 regions which are really progressing and heading the way for the others. The EU with the mandates, and the US with the incentivization scheme through IRA and other schemes at a regional level that can help and foster the demand, giving certainty, long-term certainty as well, to production projects, to investors. And this is what is missing in the rest of the world. Having said that, it's not enough. We know that the voluntary demand and bridging the gap, the cost gap between SAF and kerosene will be also a key issue. And so the voluntary demand will be very important on top of the regulatory demand, which is still weak as of today. So we believe that at Airbus, everyone should be responsible as well, and we are taking our responsibility. For instance, as a corporate traveler, we are progressively increasing the selection of SAF in our flying options. We introduced SAF, for instance, on some of our shuttles, which are connecting some of our European sites between Toulouse and Hamburg, for instance, or in domestic flights within France. So progressively, we try to ramp up as well the use of SAF for our own purpose, I would say, for business travel. And I would invite everyone as well in the room to keep this in mind. As a traveler, you also have maybe the option to select SAF at some point from an airline and to materialize the demand, the voluntary demand, which is really too weak as of today.
Got it, understood. And you mentioned the kind of the questions around willingness to pay, and maybe that's a good opportunity to just come back to the two of you over there in terms of what makes you hopeful that, you know, or confident that, you know, you can compete in terms of, you know, eventually in terms of costs. Are you saying, you know, this will only work with incentives and with, you know, mandates and regulatory push, or, you know, what can help to actually get us there that we maybe at some point don't need these subsidies and this support in CO2, etc.?
Yes, let's say as FEV, we are also a funding member of H2 Global actually, and that instrument is of course very helpful to, as you as Argus Media, to get first price signals into the market on green energy. The first project, of course, are always the ones which have all the pain, and we still need them. That means we need some subsidy or whatever to start some first projects. But I really see the price of these fuels coming down very rapidly once we have a bit of mass production or a bit of production into the system. And price coming down because there's more confidence on the bank side, and you know, everybody puts risk on margin on top, and in the end it's bloody expensive. It's not because the process is expensive, it's just because the experience is not there. And the mass production or whatever serious production of components is not there yet. But once we have that, I think that there is no reason why hydrogen should cost more than €2 a kilo, you know, produced in spaces like here or Middle East, wherever. There is no reason why it should be more expensive. It's just the missing experience, the missing trust of the banks, bankability, infrastructure. So there is a bit of a hurdle. It's a massive hurdle. So for that we need subsidy. But on long term, I don't see that the prices measure impact. We calculate also for our gasoline project. If you blend it in 1% into a fuel, it's a massive amount of energy. The customer won't notice. If you pay €3.50 a liter, nobody notices because 1%, you know, disappears in the 99%. So the ramp up to 5% will already bring the price down to below €2, and then you still don't notice. So, you know, the ramp-in phase is not the tricky one in terms of the customer, in my view. Also, the flight ticket for 2% SAF will not destroy the flying business. That's not I don't think so, yeah? It's just the brave ones to bring this €6 into the market first and killing themselves by doing this project. That is a tricky one, which needs subsidies. Yeah?
Got it. Younes, I don't know if you've got anything to add to that.
Just to add to that, in our context, from the perspective of our project, we are making two bets in parallel. So on one side, you have the traditional fuels. Obviously, today there is no economic sense for operators to just make the switch with the snap of a finger from traditional fuels to sustainable fuels unless you take the element of CO2 costs into the equation. And so we believe that with the existing and upcoming regulations, governments will be able to set up a fair price for CO2 so that we could be comparing apples and apples. On the sustainable fuels side, we are betting on, well, three key elements. The first one is the price of electricity, which is between 50% and 70% of the total cost of e-fuels. And I think in Dakhla we have one of the spots with the cheapest electricity worldwide. The second element is the application of Moore's law in the sector, meaning that as the years go by, the cost of technology will go down, and so this will contribute to bringing the cost of e-fuels further down. And then the third element is what, again, I'm always referring to the Moroccan offer for green hydrogen, the element of massification or mutualization of common infrastructure, and so that's also another element that will contribute to bringing the cost down.
Thank you. I have one more question for Gilles and Yassin, but before I ask that, I just want to see if there are any questions from the audience before I ask that to wrap up. It's a bit dark and difficult to see, but please make yourself known if you do have any questions. Else you maybe have one more minute to think, because then I'm going to ask my question first. And that's, I realize you're both quite hopeful when it comes to, in the long run, talking about direct hydrogen use as well. A lot further down the line. But what makes you confident that that's actually good? Because I know not everyone necessarily agrees with that view, that will actually ever really become much of a thing. Why do you think it will be? Why do you think it has to?
Well, I'd like to be very realistic. E-fuels are how do you say it, they're bridging the gap until the aviation sector is ready in the future to be able to fly on hydrogen. So I believe in SAF because it's a pragmatic solution for now. We have to start using it and getting used to it and adapting it in terms of prices. But also the passengers, the customers have to get used to it, because this is the future for the upcoming years. This is the most realistic solution that we have as a population in our hands, if you ask me.
What is Airbus's view on kind of the long term?
From an OEM perspective, I would say that hydrogen and the direct use of hydrogen at aircraft level is a big topic. It raises a lot of challenges, but if we want to succeed on the long run, we need to start now. And we started, in fact, a few years ago by looking at concept aircraft, to look at the storage, the fuel, the hydrogen distribution. We are talking about cryogenic form of hydrogen. We are speaking as well and collaborating with a lot of customers, of stakeholders, because beyond the aircraft, it's about the whole infrastructures that will have to be prepared and set up at airport level in order to welcome, I would say, the aircraft, the hydrogen-powered aircraft. We know it's a long shot. 2035 is not tomorrow. It's maybe the day after tomorrow. But it will be only the start of the journey. Because hydrogen will be very useful, not only for the decarbonization of our sector through e-fuel and through the direct usage, but also beyond 2050. Because we will have to maintain, let's say, our ambition and decrease our emissions. And the cleanest fuel, I would say, is hydrogen.
But that would certainly require quite a lot of adaptations from your end as well.
I saw a question
Is there
from
actually
the
a question?
audience,
Wonderful. Perfect. Let's take that then instead to wrap things up. If
I try to make it loud.
I think we can hear you.
Yeah. My question is, how is the scenario how you turn around between liquid fuels, let's say a kerosene type, your fleets are 20, 30 years old, and what is in between from going from SAFs to hydrogen? You need to separate the things.
I guess it's a question for me. It's for us, for OEM, as I said, we need each and every lever. So the fleet and the aircraft that we are delivering today, they will fly for the next 20, 30 years. And this is where sustainable aviation fuels will be important to decarbonize those fleets. Next, you're right, when it comes to the direct usage of hydrogen, it will be complementary. We will address it through dedicated platforms, and it will mean as well segregation of these type of fuels at airport level. So many challenges to overcome, but we need to push each and every lever in parallel, and we need to start now.
Not working, now working. Yeah, I think this is the big challenge to cope with these intermediate regimes. So wish you all the best for it.
Thank you.
Thank you. And a quick extra answer on my colleague is I'm currently talking with one of the suppliers that we have at the airport, and what we're asking now is just to blend the current kerosene. So that's the most pragmatic solution for now. Blend the kerosene that we're using for the current type of airplanes that we have in the market, the 10, 20 years old planes. So that's the most pragmatic solution for now. So yeah, that's what we have now, and that works. And well, we try to push all the airlines and the fuel suppliers. Yeah.
Thank you, and thank you also for the question. I think we have to probably wrap up, but if anyone wants to throw a last-minute question at our panelists. Anyone else? If that's not the case, I think we can wrap up here, and I would ask you all to give a warm round of applause to the great panelists, and thank you very much for the insights, gentlemen.